Chapter 2, measurements. Chapter 2 talks all about measurements that are used in chemistry. The first section of Chapter 2 introduces units of measurements. In science, chemistry, biology, physics, any subcategory, the metric system is used worldwide. It is the official system used throughout most of the world for trade as well. The SI, Système International, I'm sure students that speak French fluently can correct my pronunciation there. The U.S. customary system, USCS, customary system, is not used for scientific measurement. So units that we are accustomed to in the United States, like pounds and inches and feet and things like that, are not used for scientific measurement. They're used for commercial trade, but not for scientific measurement. So in this introductory section, we're going to be introduced to some common metric units that are used in chemistry. We will be learning the metric system also in Chapter 2 and how to do conversions within the metric system, and we will learn conversions with the metric system to the U.S. customary system and vice versa. So we will learn, how to do conversions with these systems. But for scientific measurement, the metric system is used. The metric system is a base 10 unit of measurement. Everything is in increments of 10, 10 to the first, 10 to the second, and so forth. Everything is a base 10 system. And if you think, why do we use the metric system as opposed to the U.S. customary system for scientific measurement? The U.S. customary system is a system based on arbitrary measurements. And I put an article on Canvas. It's called A Measure of Confusion. And it goes into the history of different measuring systems. For instance, a foot. You think of a foot. Okay? It's an arbitrary unit. It was based on the length of some king's foot. So you put this up to some king of wherever, from whomever, wherever, and this was the length of his actual foot. So it said, okay, well, this is a foot. Very arbitrary. And science, we don't like arbitrary things. We like them systematic. So the metric system is a much more systematic way of converting and measuring. So that is the official system used worldwide for scientific measurement. Let's look at typical units that are metric units that are used in chemistry. Typical metric units used in chemistry. Let's go through typical units of length, volume, mass, and temperature. Typical units of length that are used in chemistry are the meter and the centimeter. So here's a ruler with centimeters, okay? And you're probably all familiar with this type of ruler, okay? Usually they're sold with inches on one side and metric centimeters on the other side, okay? The meter, I don't know if it'll show in the entire video, but this is a meter stick. And 1 meter is 100 centimeters. So go from here to 0, all the way to the end of 100 centimeters is 1 meter. So centimeters and meters are typical lengths that are used in chemistry. Well, let me put the abbreviation there for centimeters. CM, okay. So they're common units for length that we use. Volume. Volume is defined as the amount of space a substance occupies. And typical units that are used in chemistry for volume are the liter and the milliliter, along with cubic centimeters and cubic meters. If I take these two bottles of water together, they make 1 liter. This is 1 liter right here. These two bottles, 1 liter. 1 liter. A milliliter is 1/100th of a liter. I have here what we call a graduated cylinder, and it's a 50 milliliter graduated cylinder. But the markings on the cylinder are in 1 milliliter increments. The markings are 1 milliliter increments. So that's 1 milliliter. Okay. 1 milliliter is equal to 1 cubic centimeter. And you say, well, how are you getting, we just got done saying that centimeters are for length. Now you're saying cubic centimeters and cubic meter are for volume. How do we get that it's cubed and that it's volume? Okay, let's say you have a rectangular prism, a box, and you measure the length of the 3 dimensions of the box. You measure its length, you measure its height, and you measure its width. As drawn on this board, roughly, they are the measurements: 4 centimeters, 10 centimeters, and 3 centimeters. When you take the volume of a rectangular prism, you multiply those 3 lengths together. Centimeters times centimeters times centimeters gives you cubic centimeters. 1 milliliter is equal to 1 cubic centimeter. And some of you may have heard the term cc, 1 cc, 2 cc. That's the same thing, cubic centimeter. Some of you may work in the healthcare environment and you hear, you need to give 5 cc's or 10 cc's needs to be prepared. Cubic centimeters, milliliters, same thing. Mass is defined as the quantity of material an object contains. Weight is mass with gravitational pull. Here on planet Earth, weight and mass are the same. But if you go beyond Earth's gravitational pull, you would get different measurements. Years ago, the Franklin Institute used to have an interactive display where you could step on the scale representative of what your weight would be on different planets in the solar system. And you would be here on planet Earth and you would step on the scale and it would give you 1 weight. And then you would jump over to the scale for Jupiter and you would see that your weight would go up by 5 times. And then you would go to Mercury and you would see that you'd weigh pretty much hardly anything. So it was an interesting display they used to have at the Franklin Institute. I know they replaced it with something else now, but I used to like that one they had where you could step on the scales and see that right away. We use the term mass more frequently in scientific measurement. Okay, the quantity of material an object contains, and the units in the metric system that we use to measure mass are commonly grams, kilograms, and milligrams. Now, gram is, even though it's the base unit for mass, a gram is very small in terms of what you think of an object that would weigh 1 gram. A penny, United States penny, has a mass of roughly 2.5 grams. 1 penny, 2.5 grams. 1 nickel is roughly 5 grams. I have a small scale here. And I'm going to show don't know if I could do it. One nickel. Sorry, trying to get it on there for you to view. Roughly about 5 grams. 1 penny. Roughly 2.5 grams. Just to give you the idea of the scale of a gram. Kilogram is a much larger unit, and a lot of times a person's mass will be measured in kilograms. We'll see when we do conversions that roughly 1 kilogram is equal to 2.2 pounds. Okay? So kilogram is a larger unit typically used for the mass of a person. Milligrams is a very small unit and is used in a lot of medicine dosages. For example, if you buy a bottle of ibuprofen, whether you buy Advil, Motrin, or store brand ibuprofen, the ibuprofen, which is the active ingredient, is in a dosage of milligrams, 200 milligrams. Okay? So milligrams is used for medicinal dosages. Temperature. Temperature is a measure of how hot or cold a substance is, and we'll talk about temperature in a bit more detail in Chapter 3. In chemistry, we will use Celsius units for temperature, or we will convert to Kelvin units, which are based off of the Celsius temperature scale. So here I have a thermometer that is strictly in degrees Celsius. Yeah, I don't know if it's really visible on here, but anyway, currently the temperature is in my home. Temperature is roughly about 21 degrees Celsius. Okay. Now here in the United States, we're accustomed to Fahrenheit temperatures, but we take all of our scientific measurements of temperature, usually in Kelvin. Typically in Celsius, and then we convert to Kelvin when necessary. Celsius temperatures are taken. Okay. So I'm talking about measurements. I'm talking about taking measurements of length, volume, mass, and temperature. Measured numbers have some degree of uncertainty associated with them. When I took these measurements and I said this is a length of 10 centimeters, this is a height of 4 centimeters, and this is a width of 3 centimeters, there is always some uncertainty associated with that measurement. And the next video is going to address what is done to confront that uncertainty in measured numbers.